right, up next we have DK Panda for X-ScaleSolutions, one of our sponsors.
So good morning again. So I wear typically 3 hats every day. So yesterday I presented my Icicle NSF AI Institute hat. My 2 other hats are my own research, which is the MHAPICH MPI library, and the 3rd hat is being the founder and CEO of this company. So today I'll be talking about the later 2 hats, more towards this commercial activities. As many of you know, we are in a very exciting phase. Machines have been coming, continuous enhancements in CPUs, GPUs and all. So today's talk will be mostly on the DPU side. So how many of you have used or heard of DPU? Okay, quite a lot. That's good. And DPU I'll try to show as an example, but this is also valid for IPU, XPU. A lot of newer technologies are coming. These solutions can be applicable there. So the broad challenge is like, how do we design the high performance and scalable middleware, and especially for taking care of all these heterogeneous resources, CPU, GPU, DPU, including even the cloud resources. So I'll start with a little bit of like overview of the X-ScaleSolutions, overview of the MHAPICH project if some of you are not familiar, but I'll try to go into a lot of details on, especially with these DPUs when they are sitting on the system. I'll introduce a concept of executive and assistant. So think of like the CPU is your executive and the DPU is your assistant. So how do you divide the work? Like divide the work in terms of like offloading communication or computation, communication plus computation, I/O, so all kinds of options exist. So I'll try to show you how we have done these things. So just to give you an overview of the X-ScaleSolutions, I'll introduce the MHAPICH project that has been running for 22 years. I'm very proud of my team. But once from the OSU side, all these solutions are available, anybody can download and use. Over the years, I received a lot of requests for providing commercial support. So that's how it started. The X-ScaleSolution, we started in 2018. And one of the business model, the part is that to really provide commercial support, you can download, but there are a lot of optimizations and all we do here. Like continuously newer hardwares are coming, and if you take a look at an MPI library, any MPI library, inside that is like 200 parameters you can tune. Okay? So many times you just download the public version, you are losing performance. Okay? And if your applications are really performance critical, we can actually tune platform specific optimizations. And here we have like a different kinds of service level agreements, basically the level 3 kind of things we provide. And also we do a lot of application specific optimization. If you are some mission critical applications and your researchers are using advanced MPI primitives, many times they crash actually, if some of you know, because none of those MPI libraries have been tested with all these advanced things, and we actually work with those application scientists. And then through that, like we are providing support to many national laboratories and international compute centers. We also work with directly to the organizations or through also third-party integrators. And these are some success stories. Actually, Lawrence Livermore National Lab is our largest customer from this company perspective. As you know, they have thousands of researchers working in really large-scale mission. One of these, you must have heard of this, NASA's DART mission, like around 1.5 years back. So they actually extensively, all the Livermore systems use MHAPICH. Okay? So we work actually with all the researchers. We have a very service level agreement with them. If anything breaks at the MPI layer or if they want some optimizations, we are able to give them solutions, in fact, in the few days, okay, so that their researchers are not getting stuck. They are able to move. The other one also, we worked with them on this nuclear fusion research. You must have heard of like around 9 months back. So I'm very proud that we are not just developing the software, but really working for the communities to go into these advanced solutions kind of things. So then, while that activities is going on, people are asking for value-added products. So this is our like a second pillar of the business model. So we have received a lot of DOE, US DOE. If some of you are familiar, they have grants called SBIR, like a Small Business Innovative Research. So these are like a product-oriented grants. So through these, actually we have enhanced several of these products, and today I'll be talking about like especially the DPU products. So we have an X-Scale HPC, X-Scale AI, but these are the products I'll be talking about. The basic MHAPICH to DPU. We have an HPL optimized for DPU. I'll try to show you that. And then also the deep learning stack. We have an X-Scale AI DPU where you can actually offload some of the parts to the DPU. So those are the three things. I'll go into more details. So just to give you the overview of the MHAPIS project, if some of you are not familiar, we started this project of day one of InfiniBand. If you remember, go back October 2000, InfiniBand standard was introduced. Prior to that, in my group, we were working with Myrinet Quadrix. I think some of you old timers might be knowing those technologies. So when InfiniBand came, we were the very first ones to really jump in to have an MPI. People didn't know how to actually run MPI or design an MPI library over InfiniBand. And we had the first demonstration almost 20 years back, 21 years back at the Supercomputing O2 and in Baltimore. And that time, like running an MPI on an 8-node InfiniBand cluster, okay? That was a big challenge, 8-node. Now over the years, people have been adding 000s, 8,000, 16,000 nodes are coming. So we have been in that ecosystem. So that's why, again, I were proud of my team. We have a lot of different releases. Of course, we started with InfiniBand. But now we support everything. You talk any high performance networks, we support. And very latest, we have started a new version here, MHAPIS Plus, which supports actually OFI as well as UCX. This community is bifurcating. So irrespective of whichever network you want to use, we actually provide the support. So currently, these are being used by more than 3,000 organizations. And just from our OISU site, we have crossed 1.7 million downloads, just from OISU site. Of course, it's a part of all other open HPC, SPAC, all those other stacks, vendor stacks. We don't keep track of those. But more importantly, we also work with a lot of organizations to have our libraries on the top 500 systems. So this is the very broad architecture. I don't want to go into details. Like these are all our different networking technologies, the CPU, GPU, DPU technology. These are our actually from the OISU side, the research. Like anytime a technology has some new features, we come up with publications, we publish, and in 6 to 9 months, actually, we push it. Okay? So even within OISU also, we have almost 200 servers continuously doing QA testing. Okay? And we have dedicated staffs, engineers, in addition to the students to make this quality product. And we started with HPC, but gradually, actually, we have been working on this converged software stack. I think you heard from Santanu, like all these HPC AI, these workflows are no longer restricted to just HPC. People want HPC, AI, big data. We also heard from the previous speaker about Dask. So what we are trying to do, all these stacks, of course, need performance and scalability. And people have some customized solutions. So instead of running some 10 libraries, we are trying to normalize to MPI library, because every time a new network comes, MPI library is there. Okay, so we have introduced, in addition to our basic MPI, we have MPI for DL. You can actually learn TensorFlow, PyTorch, everything over MPI. Same thing, QML, you can run with MPI. Spark, you can now run on MPI. Okay, and same thing also Dask. So we are trying to bring that normalization. So as long as you just install our libraries, you are ready to go with very good performance and scalability. So with that, let me go into the DPU part, which is most focused on this talk. So I'll start with the first non-blocking collectives, and then gradually I'll go into more details. So this is kind of like a Bluefield 3 DPU architecture. I mean, we have a set of processors, and then of course there are Arduino engines, there are all these ARM cores. So as I said, I call this like an executive and secretaries, or assistants you can say. Just like any organizations, it works like you have a manager. Of course, the manager, you can do everything, all right? But typically it doesn't happen because there is a cost associated with it, and you want some overlap because manager or executive has to do too many things. So the question is how much I can offload so that I get good overlap, and then it helps me in having a good solution with a reduced time. So that is the kind of the paradigm we are taking here. And of course, these answers can change, whether it is a Bluefield 2 versus a Bluefield 3, or it's an IPU. So you have to study internally and then see what works. And of course, there is a cost aspect of it. I'll not touch that cost. I know, Stig, you asked me the yesterday question. So cost, I'll leave it to the vendors who are out there. So we'll ask the performance. I'll try to show how much you can achieve. And then it's the question of the vendors, what price they will charge you. And then it is left for the HPC centers like Paul and Mark to decide whether to use those technologies or not. Okay, so I'll start with these collectives. Like a MPI, there is all these collective operations. Blocking collectives has been there for many years. A lot of applications use. So typically, what happens? Let's say you do all-to-all. You start the all-to-all in the blocking. Basically, there is no overlap. So while the all-to-all is happening, CPUs are just remaining idle. Okay, so you're not getting good performance. And then the question is like, hey, since there is no overlap, you don't get good performance. And especially if the system size scales, you are communication bound. Okay, and that's what happens in most of the modern applications and systems. So this is where non-blocking collectives was introduced. Okay, so that means I can initiate. Okay, it's just like means you have an assistant and you say, oh, I want like this Zoom call to be set up with 20 people. Instead of you doing, you offload that to your assistant and let the assistant set up, find out when to meet, a doodle poll, and all, come up with the time, and you are not getting blocked. You can continue. So that is the whole idea. But then the question is, like, especially if you see here, like the compute is happening, then the communication still you need to participate. Okay, because all these operations like reduction or all-to-all, sometime you need to progress. Okay, like whether just like your assistant, you may need to check, saying, okay, whether this mail has arrived, or can I do it tomorrow, or some other calls have come. Okay, so this is where, of course, in the MPI community, people have been providing some software-based solution who will progress the communication, but there is no ideal solution. Okay, so this is where actually DPU shines. Okay, and I'll show you how to do this. Now, if you take a look at this like a node 1, node 2, this is the host memory. Of course, the question is, how do I communicate? So a few years, until last year, NVIDIA has introduced this saying, okay, I can do an RDMA read to DPU memory and do an RDMA write. Okay, but then you do a copy, and then the performance was not good. Last year, they introduced something new called a GVMI, Guest Virtual Machine ID, so that you can actually provide a key to the DPU. Now the DPU can actually copy data from host memory to another host memory. You can do directly DMA. Okay, it's just like your secretary can take things from your folder and then move it to some other folder or send it to somebody else instead of you going to the secretary and giving the things. Okay, so that's what actually we have used here, and so this is what we have, the MRAPIS to DPU library, and I'll try to show you some numbers. So starting with, like, let's say all-to-all, non-blocking all-to-all, that is the most dense collectives. And if you see, this is like a Bluefield 2 on the 32 nodes overlap, like how much overlap we can achieve in this operation. And those of you who are familiar, we have a lot of OISU micro benchmarks. I think people know that is also from my group. So we have standardized way to measure kind of things. So here you'll see, this is the basic MRAPIS 2, especially you don't get a lot of overlap. Okay, but now if you go to the MRAPIS 2 DPU, you can get complete overlap, like almost 100% overlap. So now if I take it to a real all-to-all operation, so this is a non-blocking all-to-all operation, here I'm trying to show. So the red one is actually the basic MRAPIS 2, and this is the MRAPIS 2 DPU. And note that this is for the complete thing, compute plus communication. We are not just measuring communication, because we want to exploit that overlap. And here you can see the non-blocking all-to-all, I can actually accelerate by 22%, 21%, depending on, like, this is a 32 node, 16 ppm, like a 500 per process, 1000 process kind of things. So then, of course, this is just at a collective level. The question is, what happens at an application level? Now here there is a catch, just like, let's say you have been working as a manager alone, and all of a sudden you hired 2 assistants. Okay, you have money, you got some grants, you have to rethink your workflow. You cannot operate like in your old mode, saying I'll do everything. Okay, so the same thing comes. So now since we have a DPU can offload, you need to rethink the application. That means here we took an P3D FFT application, which uses non-blocking all-to-all in an extensive manner. So instead of doing the computation and doing I all-to-all and waiting, I can actually rearrange. That means I do some computation, initiate the all-to-all. While the all-to-all is happening, I can do more computation. And this is where I see the benefit. Okay, so it will take some effort. The existing code may not run. So if you do these reorganizations, so this is what we see, like 1000 process runs at an application level, P3D FFT. here you will see like a 18%, 21% benefit you see here. And then this is on the Bluefield 3, the 16 nodes. These are all the numbers. We are getting it from the NVIDIA. They have the NVIDIA Center public clusters. So this is where we have taken the numbers. I don't have access to 1,000 node DPUs yet. If any one of you have that, I will be very happy to work with you. But that's why these are like a 512,000 process run. But here you will see the same thing, like a 17%, 18% comes. So then next what we did is Bcast, like a broadcast. Non-blocking broadcast, again, gets used in a lot of applications. Similar kind of thing you see. The same idea, I don't want to go into details. Just at a non-blocking Bcast, you will see 58%, 48% kind of benefit. Just the collectives being enhanced. And one of the application is HPL. I'm sure all of you are familiar with HPL. HPL actually uses the non-blocking Bcast, and we modified that HPL. So we have actually an X-Scale HPL version for DPU, and depending on the system size and all, and this is the CPU HPL, not yet GPU HPL. That is our next goal. Here you will see, like depending on your problem size and all, at an HPL level, without doing anything else, we can boost the performance by 16%, 17% and all. Okay, I know in the top 500 ranking, people struggle. So if you can get boost 15%, your rank will suddenly go up. Kind of things, and any other application which are using like the kernels, like HPL, you can get the benefits. And now recently we have done the I-all-to-all-V. Okay, this is a vector version of I-all-to-all. A lot of applications use. Similarly, you see like at a collective level, you get almost 68%, 67% benefits. And that is on the like a x86 node. These are the AMD nodes with EPYC. Similar kind of things you see 39%, 34% kind of things. And then we took this XCompact 3D code. I think this is a UK code. We have been working, I think Paul, some of you are familiar. So nobody was able to show benefits. They were able to show if you go 3%, 4%. So now we have pushed it to 10%. Okay, it's not a very impressive number, but this is a very complex code. It doesn't have a lot of overlap capability, but still we are able to squeeze 10% in 1,000 process. Run here. So then the question is, these are all collectives. The question is, can I generalize it? Okay, so here let me show you for point-to-point, especially point-to-point non-blocking, extensively used in a lot of applications. Okay, so this is what we started doing. So, and especially stencil operation. Let's say 3D stencil, 4D, 5D, a lot of applications use this. And what we have done is, we have offloaded this MPI I-send and MPI I-receive to the DPU. Okay, especially the progress part. And now you will see that this is like a 3D stencil overlap. You will get like an 18% benefit in 512 process run. Then we extended it to PETC. I don't know how many of you have heard of PETC. That is a very big community code. And that we have been able to accelerate. You see 24% benefit at the PETC level, okay, by offloading to the DPU and doing appropriate changes to the public version of the PETC. And here we are able to offload both compute and communication. Okay, not just communication. So we are gradually expanding our capabilities, what DPU can do, and how exactly to match it with the CPU capabilities. And then finally, let me go into the DL training. I know a lot of have been talking about all this DL training. Everybody wants to accelerate it. So if you take a look at the typically like any DL training, you have data augmentation, the training, validation, and also many times you need to use this checkpoint, which is like an I/O. And especially as the model increases and your system increases, the I/O actually, the checkpoint time becomes more and more dominant. So then the question is, what do I offload? Okay. So here we have a version X-Scale AI DPU package. So now if I take just the compute part, even though the DPU cores are not that like a beefy, but still it has some capabilities. Okay, it's just like, again, think of like a manager and assistant. Okay, if you have enough budget to hire 2 more managers, that is good for you. Okay, but they will be expensive. Now the question is, the assistants are there, they are not that expensive, but can you still offload? Okay, and that's what we have done here. So here you will see around like this is like a ResNet 20v1 model on the CFAR data set with the Bluefield 3. We are able to get like around 20% benefits, accelerate the DL training. And these are very latest results. We have offloaded the checkpoint in the DL training. Okay? And especially if you see the number of nodes increases, your overall the execution time is reducing, but your I/O checkpointing time is increasing. And that is a very nice way that I/O checkpointing we can offload to DPU, because these are typically asynchronous operation, and they don't have to be in the critical path. So you just give it to your thing, just like I said, give some workload to your setting of Zoom calls or sending mails to your assistants. These I/O operations can be offloaded. Okay, and that's what you see, almost 30-35% benefits we see by doing this. So these are the kind of the things we have been working from the company side, and these are all the products. So I just want to indicate. So this is especially the DPU technology. As you know, it provides novel ways to offload computation, communication, and I/O. And so I have demonstrated here how exactly to take the advantage of DPU technologies, and it has a lot of promise. Okay, but again, the technology is evolving. Bluefield 2 to Bluefield 3, then I don't know whatever the next technology will come, or IPU. But for all these technologies, they have potential, and especially when we are talking about a post X-Scale, and people have been talking about Zetascale, you will see these kind of solutions will be very important. And we'll be very happy to get engaged with, if you have some large-scale system. With Paul, we have access to some of their systems. If other people here in UK have larger DPU test beds, applications where you want to accelerate mission-critical applications, we'll be very happy to work with you. So with this, I'll close here, and if there are any quick questions, I'll be happy to answer.